Dear students, good morning. Now, all of you try to recollect what you have learned in previous physics class. I taught you about equations of motion of a uniformly accelerated body along a straight line, their derivations by graphical method and numerical part 1. Today class, I am going to solve numerical part 2. Let me discuss the first question. The question is, the graph given alongside shows how the speed of a car changes with time. The first part of the question is, what is the initial speed of the car? Second is, what is the maximum speed attained by the car? Third one is, which part of the graph shows zero acceleration? Fourth one is, which part of the graph shows varying retardation? And fifth one is, find the distance traveled by it from 3rd hour to 8th hour. The first part of the question is to find the initial speed of the car. What is the initial speed? It is the speed when time t is equal to 0 hour. Here 10 km per hour is the initial speed of the car, which is shown by the starting point A of the graph. Second one is, what is the maximum speed of the car? The maximum speed is 35 km per hour. See the points B and C. From this graph, BC is the topmost part of the graph, which indicates the maximum speed, which is read as 35 km per hour. Third one is, which part of the graph indicates zero acceleration? From this graph, the part BC is parallel to the x-axis, which shows that the speed is uniform. Here there is no acceleration. Fourth one is, which part of the graph shows varying retardation? What is varying retardation? It means that decreasing speed is not uniformly. Hence, graphical part should be the curve down. Here, which part is curve down? The part CD is the curve down, which shows that there is no acceleration. And last one is to calculate the distance traveled from 3rd hour to 8th hour. It is the time duration of 5 hours. Here the graph is speed time graph. So the area enclosed by the graph with respect to the corresponding time intervals represented in x-axis gives the distance traveled. That is, area enclosed is the area below the BC of the VT graph, which is the area of the rectangle. It is equal to length into breadth, or breadth into length, is equal to B into L. V is 35 minus 0 km per hour and T is 8 minus 3 hour, is equal to velocity into time is equal to 35 minus 0 km per hour into 8 minus 3 hour is equal to 35 into 5 is equal to 175 km. The second question is, the speed time graph for a cyclist is shown in given figure. Find first one its acceleration, second one its velocity, and third one the distance covered by the cyclist in 15 seconds. How can it be solved? Let me see the solution. First one, when its velocity is not changing, acceleration is equal to 0. We know that acceleration is produced by either change in magnitude or direction of velocity or both. Second one, From this graph, it is seen that the velocity is a constant value. So we can say the velocity 20 meter per second. And third part is we have to calculate the distance covered by the car in 15 seconds. Since it is the velocity time graph, the distance covered is obtained by area of the figure enclosed under VT graph. Here area enclosed is equal to area of the rectangle. You know the area of the rectangle is equal to length into breadth or breadth into length. Here breadth is velocity and length is time. So we have to substituting these values. Distance d or s is equal to 20 meter per second into 15 seconds is equal to 300 meter. The third question is A. Find how far does the car travel in first 4 seconds. Shade the area on the graph that represents the distance traveled by the car during the period. B. Which part of the graph represents uniform motion of the car? See the shaded region in this graph. What is it represented? It gives the distance traveled by the car in the first 4 seconds. The area under the slope of the speed time graph gives the distance traveled by an object. So we have to calculate first the distance traveled by the car in this time interval. At first, we have to count the number of full squares and the number of half squares which is under the graph in this time interval. It gives the distance traveled by it. Thus, the total area of the squares, which is the sum of full squares and half squares, will give the distance traveled by the car in 4 seconds. For this calculation, first you are introduced how to take the scale of the graph. This is requirement for the calculations. On the time axis, let me take 5 squares is equal to 2 seconds. Therefore, 1 square is equal to 2 by 5 seconds. On the speed axis, let me take 3 squares is equal to 2 meter per second. Therefore, 1 square is equal to 2 by 3 meter per second. Thus, area of 1 square is equal to 2 by 5 second into 2 by 3 meter per second. That will be equal to 4 by 15 meter. Therefore, area of 62 squares is equal to 4 by 15 meter into 62 meter per second. It will be equal to 248 divided by 15 meter is equal to 16.53 meter. So the car travels 16.53 meter in first 4 seconds. Second part of the question is the part Mn of the graph represents uniform motion of the car. It is seen from the graph. Next, let me discuss how to solve the fourth question. The question is a stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? What should be its solution given that its initial velocity u is equal to 5 meter per second. Final velocity v is equal to 0 meter per second. Here the stone which is thrown up vertically up, whose velocity decreases and reach to the maximum height when velocity will be equal to 0. That is, final velocity v is equal to 0. Since from where the stone starts falling downward, its velocity will become 0 at first. That is, initial velocity will be equal to 0. The acceleration of the stone in the downward direction a is equal to 10 meter per second square. It is a positive acceleration. Here, the stone's acceleration to be considered a is equal to minus 10 meter per second square. The negative sign shows that it is the retardation when the stone moves in upward direction. It is given in the question. Then its velocity is decreasing, so acceleration is taken as negative. Here we have to consider the upward motion. By these questions, we have to find height, that is distance s, and time t taken to reach the height. Here we use the third equation of motion. V square minus u square is equal to 2as. Then v square is equal to u square plus 2as. Substituting these values of v, u and a, we get 0 is equal to 5 meter per second whole square plus 2 into minus 10 meter per second square into s. Separately taking s, we get s is equal to 25 meter square s square divided by 20 meter per second square is equal to 1.25 meter. Now we have to calculate the time t. We use the first equation of motion. We know v is equal to u plus at. V minus u is equal to at. And t is equal to v minus u divided by a. Here we have to substitute the value of t, which gives 5 divided by 10 is equal to 1 by 2 second is equal to 0.5 second. Thus, the stone will attain a height of 1.25 meter, which is the maximum height reached by the stone, and time taken by the stone to reach this maximum height t is equal to 0.5 second. The fifth question is, a driver of a car traveling at a speed of 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at a speed of 3 km per hour in another car applies his brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graphs for the two cars. Which of the two cars traveled farther after the brakes were applied? Given that two cars travel at two different speeds initially and finally come to halt after the brakes applied, can you say which car takes more time to stop, first car or the second one? Second one. It takes 10 seconds to stop. Here we have to compare the distances traveled by both of them each other and state whether which car travel more distance. In this case, you have to use speed time graphs of two cars which help to find the distances traveled. We know this is one of the applications of speed time graph. Given for the first car, the initial speed u is equal to 52 km per hour. And then we have to convert kilometer per hour into corresponding meter per second. What we have to do? Multiplying it by 5 by 18. So u is equal to 52 into 5 by 18 is equal to 14.4 meter per second. Final velocity v is equal to 0 since the car stops, and time taken by the car is equal to 5 seconds. For the second car, its initial speed u is equal to 3 km per hour, which is equal to 3 into 5 by 18 is equal to 9.4 meter per second. Here time taken t is equal to 10 seconds and its final velocity v is equal to 0 since the car also stops. In the graph, blue slope shows the velocity of the first car and green slope shows the velocity of the second car. Here distance is calculated by the area under the slope of the graph. Thus, distance traveled by the first car is equal to area of the right triangle OAD. We know that area of the right triangle is equal to 1 by 2 BH. Then S is equal to 1 by 2 into OD into OA. Here OD as B, OA as H, and also OD is equal to 14.4 meter per second and OA is equal to 5 seconds, which are already marked in the graph. Then S is equal to 1 by 2 into 14.4 meter per second into 5 seconds is equal to 7.2 meter per second into 5 seconds is equal to 36 meter. For the second car, distance traveled S is equal to area of the right triangle OBC is equal to 1 by 2 BH is equal to 1 by 2 into OC into OB. Here OC as B and OB as H, where OC is equal to 9.4 meter per second and OB is equal to 10 seconds, which are also marked in the graph. So S is equal to 1 by 2 into 9.4 meter per second into 10 seconds is equal to 4.7 meter per second into 10 seconds is equal to 47 meter. Now you compare the distance traveled by both of them, which is more. You can say the distance traveled by the second car is more than first car. So second car travels farther. The sixth question is, an electron moving with a velocity of 5 into 10 the power of 4 meter per second enters into a uniform electric field and acquires a uniform acceleration of 10 the power of 4 meter per second square in the direction of its initial motion. Calculate first one, the time in which the electron would acquire a velocity double of its velocity, and second, the distance the electron would cover in this time. Do you know what is an electron? Electron is a negatively charged particle which is revolving around a nucleus in an atom. What is a uniform electric field? The uniform electric field is the electric field which is in uniform nature, that is, it is the region surrounded with the electrically charged part, or it is the region which consisting of electric force or force field surrounded with the negatively charged region or part. Given that the initial velocity u is equal to 5 into 10 raised to 4 meter per second, acceleration a is equal to 10 raised to 4 meter per second square, and final velocity v is equal to 2u, since the velocity at last becomes 2 times of the initial velocity, then it is equal to 2 into 5 into 10 raised to 4 meter per second. Finally, it is equal to 10 into 10 raised to 4 meter per second. To find time t, we use the first equation of motion. We know v is equal to u plus at. Just by rearranging this equation, t gives to v minus u divided by a, substituting these values of v, u and a. Here 10 into 10 raised to 4 minus 5 into 10 raised to 4, which is divided by 10 raised to 4, is equal to 10 minus 5 into 10 raised to 4 divided by 10 raised to 4. 10 raised to 4, 10 raised to 4 is cancelled each other in numerator and denominator. It will be equal to 2 seconds. And second, we know second equation of motion, s is equal to ut plus half at square. We calculate the distance covered by the electron in this time. Substituting these values of u, t and a, we get 37.5 into 10 raised to 4 meter. It is the distance covered by the electron in this time. And last question is, a bus starting from rest moves with uniform acceleration of 0.1 meter per second square for 2 minutes. Find the speed acquired and distance traveled. As the bus starts from rest, its initial velocity u is equal to 0. Here, the acceleration is the positive acceleration. A is equal to 0.1 meter per second square. Time t is equal to 2 minutes, which we have to convert into corresponding seconds. That is equal to 2 into 60 is equal to 120 seconds. Since 1 minute is equal to 60 seconds, we have to convert into corresponding seconds. Final velocity and distance are the unknown values. First, we have to calculate the final velocity v by applying first equation of motion. We have v is equal to u plus at. On substituting the values of u, a and t, that is equal to 0 plus 0.1 into 120. Here v is equal to 12 meter per second. Now we are going to calculate the distance s by applying the second equation of motion. S is equal to ut plus half at square. On substituting the values of u, t and a, here u is equal to 0, t is equal to 120 second and a is equal to 0.1 meter per second square. We get s is equal to 720 meter. Dear students, please you note down the homework given in the slide which is necessary to work out today. Thank you.